All right, well, I'm going to go ahead and get this stream started now. Hopefully, there's no problem with audio or video or anything. I see that the overlays for the chat window and stuff are a little bit wonky at the moment. We'll deal with that in a little bit. So today I'm going to be doing a code review of the compile time regular expressions from Hannah. And this is an absolutely amazing library written for C++ by Hannah. She started it several years ago. And well, I mean, it's incredible, so I don't really expect to find a whole lot, but she has asked a couple of times that I actually do a live stream about a code review of her project, that is. So I'm going to go ahead and do that. And now you'll note, probably if you've been a longtime viewer of my YouTube channels and stuff, that I've never had any kind of sponsorship before. This episode is actually done in collaboration with JetBrains and Sea Lion, and I approached them about this because I'm already using Sea Lion in my live streams very often. It's a great way to browse through the source code. That's actually it's spectacular for these code reviews because I can easily click and jump between things. So yeah, this episode is done in collaborations with JetBrains and Sea Lion, so I'll have the logo down there at the bottom. Hopefully it won't be too intrusive, and there's a URL you can go to if you want more information about that. Hannah said that she would be coming, so I don't know. I don't see her in the chat yet, but we'll see. Hopefully she will be here. Yeah, so it's all live. I should probably have tweeted this, that I am actually going live now. Let's see if I can do that real quick. All right, quick tweet there to make sure everyone knows what page we're on. What's the difference between Sea Lion and Visual Studio? They're completely different products. They're completely different products. Sea Lion works on Linux, which is one reason why I like it. All right, so CTRE, if you're not familiar with it, let's just do a quick jump into this. It's funny because Hannah said, don't look at the test because that's where the worst code is, but we're definitely going to have to jump into the test. But basically, compile time regular expressions, you can give the compiler what you want your regular expression to be and then do a match on it. And the reason this is so unbelievably impressive, now let's scroll down here. There's all kinds of examples, and I'm not going to dig into a whole lot on how to use CTRE. I will say I do use it in a few projects. I'm just going to click on this compiler explorer link real quick. Welcome, Cornton. Now, what makes CTRE so just unbelievable is we have this, okay, she gave this example, extract number. It takes a string view and it returns an optional string view if it actually found a number in the middle of this regular expression. And I have to be perfectly honest, I don't really understand what this regular expression does because I don't know what plus plus does in a regular expression. But this is the start of string, A to Z, some number of times, 0 through 9, some number of times, end of string. And for simpler regular expressions, you can just read the disassembly that's been generated here. Swear, Matt. All right. So just for the sake of simplifying this, to see if we can, yeah, look at this. So it jumps in the RDI, RSI, going to be the first couple of parameters. I don't even know what this does. It loops through here pretty... No, sorry. It's a little bit beyond me to just jump right in and look at the disassembly on this. But the point is, it generates something that's orders of magnitude faster and simpler and faster to compile than our standard regular expression libraries. Oh, I see. Plus plus is possessive. Ah, how well does it perform on the Commodore 64? You know what? We'll see how long this stream goes, and we'll see if we can get this to compile on the Commodore 64, for the Commodore 64. And I'm almost positive that we could. Yes. We'll see. We might play with that. We might come back to that. Okay, I lost my mouse cursor. There we go. All right, so that's enough about CTRE. Compile time, regular expressions, that's the point here. So I'm going to... you want safe regex on an ARM Cortex. This should do it. I have no doubt that it should do this. I'm 99% positive that I could get it to compile with my current Commodore 64 stuff. And if I can do that, then it's going to work on your ARM Cortex. All right, so let's jump into the source code. I'm going to use CLine, like I said. That's what I would have naturally done anyhow. So I'm going to come into here. I haven't even checked it out yet. I do have CLine running. So let's just go ahead and get a clone. What am I doing? Looks like I have no idea what I'm doing at the moment, doesn't it? All right, we'll clone that. And then we're going to open it in CLine. And now pay no attention to this Commodore 64 for C++ stuff that you see in the background here. I just did this. Look, it's like a list of all the things that I've live streamed on here. Compile time, regular expressions. Let's see what it does. It is a CMake project. Oh, there's Hannah. Okay. String view is safe? Yes, string view is safe. String view is very simple. All right. I'm going to say trust the project. I want to open it in this window. Now, one reason I waited to do this particular project with CLine is it's only been in the last few months that CLine's tools have actually been able to handle CTRE. So it's also kind of a test of CLine right now to see if it's doing everything that I want it to do for browsing this stuff. All right, so let's see. Now, it's not immediately obvious to me, like, should I be looking in the single header or should I be looking in the include? Because if you use CTRE, then you're probably used to seeing just the single CTRE.hpp file. And it'd be interesting just in general to see what what CLine can do with this. If constexpr is a C++17 extension. So for some reason, it's not seeing that I'm in C++17 mode right now, but that's in the single header. Let's see if I go into the not single header. Oh my goodness gracious, there's way more to this than I thought that there was. Well, I tend to just pick a file and start digging into it. Yeah, no, CLine's not that great with very large files, but I'm going to just say for the record that this, by the definition of projects that I've been working on lately, is not a very large single header. This is only 5,290 lines, 5,293 lines. I've been working on projects that have like 10,000 line things, and CLine then gives up on a lot of those. This is probably not the best way to explore this code. And it does say this file does not belong to any project target. That's why it doesn't know what C++ standard it should be using. So I guess we'll start digging down this way. And I just picked a random file, atoms. It's alphabetically at the top in the CTRE folder. What is .hpp extension? That is a C++ header. I strongly recommend using HPP instead of .h when you're using C++ because C++ is not C. If you have a .h file, there's some sort of implication here that you could include that in your C project. And if you have a bunch of C++ stuff in it, you can't. So let's see. I'm going to try turning back on the chat overlay and see how it looks. It's kind of in the way. Ooh, wrong window. Let's see what happens if I kind of hide it up here. Yeah, that should work all right, I think. It shouldn't get in the way too much. We'll see. We'll move it around again if we need to. Okay, special helpers for matching. What does this do? What's a thing called accept? Oh, interesting. So C-line definitely got confused here. When I clicked on it to say, show me the definition of it, it took me to the single header, even though it knows that the single header is not part of the project. So that's a little bit of a fail. But I should be able to do a control click on this and see where and how it is used. So it's a tag type of some sort, just an empty struct. Okay. AST for regular expressions. So this seems to be a lot of code that I can understand. Okay, so I mean, maybe it's worth commenting here, since this is a highly specialized technical kind of thing, that maybe a couple of other comments for what these particular things do would be useful, but maybe not, because if you know regular expressions, you know what a plus is, you know what a star is, you know what a plus, lazy plus is, and a lazy star is. So maybe it's not necessary to have extra comments here. No, I don't need to get the project compiling in C-line before it syncs up well. It does a pretty good job of that already here. So I'm going to go ahead and pull up one of the tests. And I was looking at the isPrime test a moment ago. I expect, let's see. No viable conversion from... Oh, sad. All right, maybe I'll go ahead and tell it to build and see what it does. Build finished. Okay. Oh, continuous build. Let's build the test project. Make sure everything is set up correctly. It is not set up correctly. What is going on? Go away. Unable to find string literal operator. Hannah, what does that mean? It's not a record for me to be confused by code. Just for the record. I don't know what that means. I don't know if that's because the compiler that it's currently using is not good enough. What am I doing here? Toolchain default. Manage toolchains. Default toolchain is using user bin C++. Which is GCC 10.2. GCC doesn't implement template fixed string operator quote, and the CMake project is set up for 17. Okay. So it's not surprising, it sounds like, from what Hannah just said, that from the test perspective, CLion with the default settings is going to be confused. Clang 12 doesn't exist yet, right? I have Clang 11 installed. What the heck? I'll try switching it over to Clang 11. And you'll all watch me sit here as I fumble my way through the toolchain settings because I don't change those things very often. Let's see, make detect. Let's add a new clone this one. I'm going to call it Clang. No, wait, what is this one set to? Oh, that one, just user bin Clang. Let's use that one. All right. I didn't actually change the tool chain. That's going to use system Clang. Debug, build Clang, compile. All right. Oh, no, I'm still getting the same error. All right, I'm not going to worry about that too much at the moment, not being able to compile that test. Someone just said, include guards contain double underscores. Yes, that is in fact undefined behavior. So you're not allowed to use double underscores in any identifier in C++. So yeah, that's undefined behavior. Okay, let's get back to where we were. I was trying to look at this is prime example, but oh, hey, okay. All right. So CLion is happy with it now, even if I wasn't able to compile it. Cool. All right, very good. So one thing I just want to point out about CTRE, if you haven't used it before, is you can see like that's calling this is prime stuff here, and CLion and CTRE integration are working together is pretty good. So if I do something like remove that, then I actually get a squiggle here on the match, and I get occurred here, blah, blah, blah. It tells me that an undefined template problem at position 13. So we actually get a compile time error from the compile time regular expressions, that there was a bug in our regular expression. I just wanted to show that. So if I take that back out again, we can actually see in our IDE that our regular expression is correct. Can't see. Oh, overlay. Sorry. All right. I'll move that. Bad times with the overlay. You know, I want to be able to use it, but it does get in the way sometimes. Yeah, sorry, Matt. Yeah, double underscores anywhere in an identifier is UB. Yes. Anything with a double underscore and it's reserved by the implementation. So yeah, sorry for when you couldn't see that. If I put an error in the regular expression, then I actually get a compile time message that the regular expression failed. Now, it is not necessarily easy to decipher why it failed, but we can put that back and see that it compiles again. So I'm trying to decide how exactly to dig into this. I'm thinking about just jumping into what is this match function that was called. So this is interesting. For whatever reason, CLion thinks that the start with, split, and tokenize things are not used, but I'm guessing that that's not correct, that it's probably just not used in some way that it can see. Yeah, message pop over again. All right, fine. I'm gonna have to get rid of it. We've been able to keep a line or two of it in the past for people who watch the stream later. All right, so Hannah said I need to go back and actually read the error. So I will see what I can see from the IDE, because that's going to be my judgment at the moment. All right. Implicit instantiation of undefined template, problem at position 13. Okay, so I know there's a problem at position 13. Error occurred here. Regular expression contains syntax error at 13. That's what I see. Is that... Am I missing anything else? Yeah, I know you can have the chat on replay on YouTube. Watch later. Anything starting with underscore and global namespace is UB as well. Anything starting with an underscore followed by a capital letter and a local namespace is UB as well. Yeah, and I'm not, just for the record, I'm not giving Hannah a hard time here for the lack of error message or the not as much error message as I would hope to have, because it's not Hannah's fault. It's what we can report at compile time in our compilers today. No, you can't. You can't really warn on it because the question was, does any compiler have a warning regarding the double underscore issue? And the answer is no, not really, because how would the compiler know if that symbol came from your standard library or your compiler, or it came from something that was provided by you? I guess I'm just gonna hide that window. All right. Okay, so I was starting to try to actually walk through this code. I don't know if I'll be able to. Let's see. So we have static, const expert inline. Oh, okay, that's interesting. Const expert implies inline. So I think that that inline is redundant, Hannah. I'm curious why you have const expert and inline in that case. These are objects that exist statically in the namespace. I don't think inline is necessary because we got static inline variables in C++17, but const expert already implied inline. Yes, pragma once is non-standard. No. Okay, so I think that this inline is redundant. I think inline on all of these things that are const expert is redundant. You can go back and check that. Or I can... let's see if we can verify that. Even with my new laptop, it still slows things down. Oh, come on now. To stream at the same time. All right. Where is const expert in the standard? Expressions. No, not const cast. Constant expressions. Const expert. Yeah. Okay, it's not in that section. So I might be crazy. I don't think I am. Const expert does not imply inline for global variables. Really? Really? At namespace scope, const expert variables are not implicitly inline? I had no idea. Now I kind of want to know. Well, someone link to me where it says it, because I am confused by that. No. Grammar statement. That's if const expert. Grammar decal. And that's the one we were just looking at. Const expert function, const expert if. Compatible. A const expert specifier used in a function or static member variable since C++ declares implicitly inline. CVP reference. Okay. All right. Very good. All right. I need to update my class notes. I didn't bring any paper with me. Okay. All right. So never mind. You can ignore me, Hannah. Okay. I just looked at this and I said, why in the world are we calling the destructor on a size T? I don't think that's what that's doing though. My brain went a little out there for a second. Yeah, I guess we're all wrong. Yeah, it must not imply inline there. All right. Someone else saying that const implies static, and at the global namespace, const implies static. Now I don't even know, we're going down a whole other road here. I mean, for the fun of it, I could try removing static, I guess, and see if it still compiles. But const expert functions and const expert constructors are implicitly inline. Yes. I thought const expert member variables were as well. That was Ali said. Oh. Static member variable declaration, const expert specifier using a function or static member variable. So a const expert static member variable is implicitly inline. Okay. All right. Yes, that's a negation of bits. And I don't know, just for the record, I just deleted static in a couple of places, and Sea Lion doesn't have a problem with it. I have no idea at this point. Yeah, so this is doing a this is negating all the bits of a size T. Which interestingly in C++23, now this doesn't actually gain us anything here, but in C++23 you could do that, but we don't have a compiler that supports it. So it's, ooh, hello. So it's kind of irrelevant, I guess. All right, use the new suffix coming in C++23. All right, yeah, so let's see. The only thing that we found so far that's worth noting is the double underscores in the identifiers, and possibly the use of static on constexpr objects in the global names and namespace level. I don't know. And I find this also just interesting, by the way, that our tools, so this is running Sea Lion's own analysis and running analysis from Clang Tidy. And we're just getting a few little yellow bar warnings here telling us that these things are never used. Although I'm assuming multi-line search actually is used somewhere. If it's not, then that implies that there might be a missing test case for some of these functions. And that might be something for Hannah to look into, since she asked for this code review. These things split, tokenize, multi-line search, and starts with. Is it possible that those functions don't have tests? I love that there's a number of experts in the room going, well, I'm not sure if that should be static constexpr inline, or if it only needs constexpr inline, or if it only needs static constexpr, or if it only needs static in, I don't know, right? So, but this would just make me ask, are there unit tests for these things? Are there tests for starts with, split, tokenize, and multi-line search? Since I'm getting some warnings that they don't seem to be used. So that might be something to look into. We did make a general comment before that Hannah already agreed with. It's possible that we might want to have a little bit of more comments on some of these things, but I don't know if you're an expert already in regular expressions. Do you need it? I know force inline, and generally I say using force inline is a bad idea. Keyword bingo, let's add volatile to it. People commenting it's both funny and reassuring. Yeah, no, volatile, Matt's being silly. He wasn't being serious that we need to add volatile to these. Although it's possible I've come up with a use case for constexpr volatile, I think. But anyhow, I'm sure that Hannah went through and figured out that force inline was actually necessary to get the code compaction that she wanted. And I've got a C++ weekly episode coming up where I actually kind of unfortunately demonstrate that force inline does something amazing to the resulting code, which I don't normally recommend, but that was probably already analyzed for what needed to be done. Okay. Some weird comments coming through. And we've got if it's Visual Studio or not. My understanding is that some compilers, now I'm really digging for things here just for the record, but checking MSC ver alone might not be good enough because I think Minchi W actually defines MSC ver, or one of these other compilers does, and __ force inline wouldn't be correct in that case, which is why things like Boost, when they try to determine what compiler they have, actually have like 3 lines of if-def around it. So, but if it hasn't caused portability problems yet, it's probably fine, but it might come up in the future. So that's interesting. Seems like a very small utility header here. I'm curious where likely and unlikely have ended up being used. I'm going to dig into that. You don't see very many use cases of, wait, what is this all if-def'd out? My compiler doesn't have CBP car8t. Greater than 2018? Weird. Unicode. Single header Unicode. Oh, okay, okay. So it's only used in the UTF-8 header. It's an interesting use case to say if the length is 1, likely, then return the result here. So I would like to see, just out of curiosity, the difference in the code generated, because I've never seen likely or unlikely used on a single statement. I've seen it used on like the if and the else. So that'd be interesting. Need to switch to C++ 20 mode. All right, I need to switch. Oops, wrong button. So this is one thing I just in general don't like about IDEs and CMake is I feel like the discoverability of what options I can pass are just like, are you going to tell me what options? What do I have to do to convince you to show me what options are available? Then I always end up doing something like, whoa, oh, there you go. Now you're opening all of the tabs. Thanks. That's really helpful. Is there a flag to put it in C++20 mode? I don't see one. Look at the background. You are doing well. What? Sorry, I'm reading the comments. I'm using Monjaro. See? Jason, Monjaro. You can see it right here. I'm using Bash with one of these add-ons that gives you power line type things. All right. Okay, I'll set CMake CXX standard equals 20. But how to do that from here is an entirely different question now, isn't it? All right, there we go. That worked. Anyhow, so I'm very curious. That is all. I'm just curious to see. I would like to compile the code a couple times and see what difference these things make, if any, or where they make difference. That's just intellectual curiosity. Operator minus minus returns a non-constant object instead of a constant object type. Really, Cling Tidy? So Cling Tidy is saying that post increment, it wants you to do that. Yeah, which then it's going to warn about the return type being const qualified. It's really weird to const qualify the return type from a function. That's weird. Oh, and I don't know how to say Monjaro. Monjaro? Monjaro? Yeah, it is an interesting question. Ask Hannah how long she's been working on this. I think it's been forever. Um, so I want to adjust a question about whether or not this makes sense, this recommendation from Cling Tidy to const qualify the pre-increment operator. Let's just give myself here some struct. And this crazy IDE that no one's ever seen before here. All right. So sure, I'm going to return an object of type S, operator plus plus, int, whatever. I'm just going to do that. So for those of you who aren't familiar with this is some of the goofiest syntax in C++. This is the pre-increment. Come on now. This is the post-increment operator. This int is a dummy placeholder. You can never use it for anything in any way. It's just there for the compiler for overload resolution to distinguish whether it's pre-increment or post-increment. So if I were to create some object of type S, this should still compile. All right. And then I want to pre-increment it. I'm going to call this one, and then it's going to implicitly return a reference to itself, right? Inline function constants were used but never defined. Yeah, fine, whatever. I know it's not defined. If I want to do post-increment, then the canonical thing to do is something like post-increment is like where canonical version of this is something like that. So that warning we were getting from Cling Tidy was saying to make the return value from this const so that it would stop you from doing something like that, I guess. So if I make that const, is that what it was saying? No. That's what it was saying. Maybe not. Hold on. I have to reject a phone call from my best friend, Spam Likely. All right. No, you don't make a you don't make an increment operator const at all. Okay. That is what it was suggesting that we do, is make the return value from it const so you can't do something like that, right? That's what it was suggesting. Okay. Can post increment be implemented with standard exchange? Probably. Probably. Maybe? No. Standard exchange never makes a copy, so you're still going to have to explicitly make a copy of yourself. I think. I haven't played with that before. All right. So yeah. So Cling Tidy is just telling us that it wants that to be const. But then that activates an entirely different Cling Tidy warning that says if you make this thing const, it may reduce code readability without improving const correctness. So thank you, Cling Tidy, for nothing in this case, but it's an interesting thing to think about. By making it const, you make it more like a built-in type. So if I have that, and I go to do that, a built-in type's not going to let you do that. So do you want it more like a built-in type? Do you want to wrestle with Cling Tidy? I don't know. That's annoying, is what that is. Uh, Someone said, don't do const old value because that will copy on return instead of move. That's not necessarily true. And this particular code, it's still going to do a return value optimization on return. So, let's see. Let's just go ahead and verify. Let's turn on some optimizations. All right, so actually, no, I'm gonna do this different. I'm gonna turn off optimizations to try to prove my point. But I'm gonna simplify the code. So this is generated, let's just gonna say 274 instructions. I'm gonna get rid of this const, and it should still be exactly the same code. If it's not, then I'll go do a bunch of research. Okay, it's exactly the same code. Now, the place where putting const here, and clang tidy will actually warn you about this now. In this case, you don't get full return value optimization anyhow, but you also are going to get, you're going to get a copy now because it has to move one or the other, and it can't because it's const. It can't do the full return value optimization thing because there's a switch and it doesn't know which version. I didn't realize that Clang 12 had been fully released, just for the record. I am not actually getting a warning yet. All right, that's not actually giving me the warning there. Anyhow, that's when you're going to get a copy with a const, but our last version we would not get a copy with a const. I'm going to go back and look at the comments again. Why use this operator plus plus instead of plus plus? It depends entirely on the situation. We can constant if we know what we're doing, and compilers will warn us. Would it make more sense to value ref qualify post increment? Yes, right. That I was thinking about that as well, Bjorn, but I had forgotten. Can you do return value optimization if your new value is not const? Yes, it can. In this case, it's going to have to pick one to do return value optimization with, and the other one becomes an implicit move if I do that. So that should have actually changed the code generation with my O0. Yeah, definitely changed the code generation here because one had to become a copy. Oh, I somehow got out of sync with my comments. CTRE pitching for standardization at any point. I think it is hoping for standardization. I'll let Hannah answer that. All right. So we're kind of going off track here, but I'm going to agree with Bjorn real quick and make this comment. Thank you, Bjorn, for bringing it back up since I had forgotten. So this says make it const, but if you had instead made it L value reference qualified, whichever order these things go in, There we go. Now this warning becomes completely meaningless because making it L value reference qualified means that it can never be done, never be called on a return value, on an R value, that is in this case. And then this becomes meaningless, but gives you the same fundamental result. They're all, I mean, you know, we're really digging into randomness here. I have no idea if any of this is useful, Hannah, or not. Oh, that's unfortunate, Hannah. She says it will never get standardized because the committee already standardized one library and they're not going to standard regular expression library. They're not going to make that mistake again. All right, so interesting use cases for likely and unlikely here. Really would like to dig into that, but I don't know how to in a simple way. Single argument constructors must be marked explicit to avoid unintentional implicit conversions. That's curiosity. So this is a range and it takes a string view. That's probably pretty low risk for that to be an implicit conversion because it's not an expensive thing to construct. But it's an interesting comment. And just out of curiosity, does that affect anything? Didn't seem to. So going back and making some of these explicit, and this is almost certainly telling us no discard. Yeah. So there's, at least in the UTF bits here, some things that could be marked no discard. Begin and end, relatively low risk. I'm kind of curious now. Let's go back to this is prime. Click back through match. Click to, let's see, this is a regular expression. Oh, did I? Okay, here we go. Force in line, regular expression. Exec with result iterator. I'd say multi-exec, exec. I would like to see no discard on some of these exec things at the least, so that whatever result you get back, like if you just made a point of calling the regular expression match and you then discard the results immediately, that's almost certainly a bug in the user code. So I would like to see some no discard on here. Do you have a way to specify a way to make constructor implicit? No, I don't think so. So if you're saying, actually, that's it's an interesting question. So C++ 20 allows this kind of thing. And no, and then clang tidy still warns you. So this would be the kind of thing I guess you might want to like no lint clang tidy on if it was intentional. Or you just turn off that warning. But in general, I wouldn't recommend turning off that warning. So it's a good question. How do you tell clang tidy, no, really, I wanted this to be implicit? What are the things in angle brackets at the beginning of the function declaration? Doesn't look like templates. That was back here. This is the IDE collapsing the templates for me because I don't necessarily care that it's template, type name, iterator, begin, iterator, end, whatever. I can look at this and see, okay, this takes 3 template parameters. I can mouse over it. So this is CLion filtering that stuff out for me. And then, oh, I see. Oh, okay. So we're back in the same header again. And these things, you look at this and your first thought is, hey, why isn't this arranged for loop? Well, it can't be. Obviously, the iterator is being carried through several different algorithms here. It's being passed to other functions. So that's fine. You know, I feel like even though I have YouTube on ultra low latency, there still seems to be a surprising amount of latency for when I'm seeing comments from people. So sorry about that. That's YouTube's problem. But I believe I answered your question, VZW Gray, and I did try that explicit false thing. Okay. Yes. All right. Brand bool operator. You know, I'm not going to say const expert any of these things now, am I? Although, Hannah, I would like to ask this question. Since this is intended to be compile time regular expressions, I don't believe you can pass a runtime string to the regular expression library. I mean, you can when you go to evaluate the regular expression, but not when you actually go to create the regular expression. Is that correct? And if that's correct, then I would say ask, actually, from a C++20 perspective, should a lot of these functions actually be made const eval? I just clicked on this because I saw this comment that it was some strange syntax for me. RE method equals void, etc. Again, that was the IDE collapsing the template for us. Those are just defaulted template parameters. Method is void, modifiers, single line. Okay, so they should be const eval. Okay, that was really me asking Hannah's opinion, just for the record, not because I still haven't pushed const eval so much. Yeah, the template keyword is there. It's just the IDE magic. Ooh. Since that's come up a couple times now, these are all IDE magic things here where it's highlighted in green. It's where the IDE has hidden it for us. All right. Old school programming is better. Okay, sure, whatever. I don't think it's worth that. One of the comments just now said that we should use a macro for CTRE const eval on C++20. You know what? I have to be perfectly honest. I don't think I would bother. Okay. Maybe it would be worth doing that const eval. The move to const eval might enable the ability to remove these force inlines because the compiler is going to evaluate anything that's const eval at compile time anyhow. So it's possible that a move to const eval for these things could result in a removal of the force inline, but that would be like an experimental project to figure out what the result was. The run function shouldn't be const eval anyhow, so it's irrelevant. But on some of them, on some of these things that are force inline, I'm saying theoretically, hypothetically, we're just doing an exploration of the code. So we can probably still make comments about no discard for some of these things. I was curious about the things that it said are unused. Try. Oh. Try extract is in fact actually completely unused, it looks like. Is it? Single header. CTRE. CTRE Unicode. Yeah, it is. Okay, so try extract is actually unused. Okay. Yeah, so it looks like some of these want some test added for them. All right. I don't know. I got lost in that file here. Let's just try random other thing here. Why is this highlighted as single argument constructed? Could be marked explicit. So that just comes up again, whether or not that's useful or not for this code. Fix me, allow end line here. Let's see something. To do. Found 51 to do items in 12 files. Docs to do, more detailed regex information. Okay. Evaluation, 4 items. To do, add support for different line endings and Unicode in a future Unicode mode. Interesting. There's lots of Unicode in here already, so I don't know what that's about, but properly match end line, okay. To do MSVC issue. Commented 3 years ago, 2.5 years ago. If I uncomment this, return it will not fail in context, but the matching result will not be correct. Ew, that sounds bad. Although I'd say over the last 2.5 years, it's possible Visual Studio has fixed that context per evaluation bug, but no way, no. Without testing. Check interaction with non-empty flag. Sounds like a test case that needs to be written still. Future pattern matching C++ feature, okay. Move dmax, okay, whatever. Yeah, it basically just writes assembly that outputs the final result. That's really what Anna is doing here. Okay, so no other real comments to make here. Okay. All right. What the heck? Why not? All right. I've also hacked on around a little bit to combine regular expressions. That would be an interesting feature to be able to do at compile time, Hannah, or unless there's something that we just keep missing here. All right, so I'm just trying to make our little list of things that we've discussed so far. Oh, right. I think I've already seen, no, okay. CNTTP, yeah, some of these things are to maintain compatibility, right? Function fixed string, parser. This is where we actually got that regular expression contained syntax error generated from. This is unfortunate, but nothing you can do about it. I hate it whenever I have to do explicit template keyword. Just find it annoying. So Hannah says she was thinking about ways of merging. What does the ampersand qualified do exactly? Okay. We have someone trolling. You know, you don't have to feed the troll, just for the record. Yeah, you can ignore the troll. If the troll gets bad, I'll mute the troll. Or if any of my moderators are in, you can mute the troll if they get bad. It's best just ignore them. Okay, so someone asked, what does the R value ref qualified do? I'm just gonna go all the way back to here. Or L value ref qualified. So this version compiles and well, it doesn't compile because I have this as const. Right now it compiles and we don't want it to. Oh wait, that's an integer, sorry, wrong line. Let's get rid of that, and put that back up. Okay. So if I make that L value reference qualified, then it must be an object that is an L value. So I can do S++ all day long, but the result of S++ is a temporary. It is not a reference, it is a temporary. It is this right here. So this temporary is an R value. Basically, that's what happens. So I can't call it because it says it must be an L value. And if I add, you can overload on L value and R value. So I can actually overload on this. And now it works because I'm getting two different functions called. And if we scroll to this, scroll, reveal linked code, there we go. Then we can actually see that we've got 1, 2, 3 calls to the L value reference qualified one, and then a fourth call to the R value reference qualified one, and that's because I do this plus plus on the result of the first one. Don't write code like this, by the way. This is just asking for weird things to happen. Yeah, dot template, it's always confusing. Const qualifying, making it so you can only call the const. Life, yeah. This will be saved. You can watch it later. If you want to make a feature request, I suggest that you go to the GitHub project and actually make the feature request there instead of just on the live stream. That would be my suggestion. Yeah, so either way of doing this makes it behave like the built-in thing. You can do it with the L value reference qualified, you can do it with a const. So it's just something to look at, something to consider. That's like super refinement of this code at this point. I don't have any. Oh, what did we comment? What was the last one? When I said maybe some more comments, Hannah agreed in the chat that yeah, there might be some places to add more comments. Like a lot of this is. I mean, it's a regex++ iterator, right? I mean, you can read the function declaration and see what it's supposed to do. Now, if there's other magic happening in here that's specific to the algorithm of handling these regular expressions, then, you know, maybe that needs to be, maybe then we need comments. No Windows, I am not going to restart to install updates. Thank you. I'm not going to add any features live on the live stream. This is Hannah's library. Multiply operator plus plus on a built-in is a UB, I think. Yeah, no, I wasn't suggesting multiple plus plus operators on a built-in. I don't think. But it seems like it's allowed for your user-defined type. I don't know. Just the question of which method do you want to choose to make something like this behave more like a built-in type? Do you want to return a const object, which is weird because it actually breaks moves? I don't recommend that. Do you want to make it L value reference qualified, or you just want to leave it alone? Hello, what's this? Expression can be simplified. Simplify expression. Huh. Oh, okay. I guess that's a thing. All right, I want to see something. Value type. Current match. So this is this is equivalent to a C-style cast. It can coerce pretty much anything into a bool. So I generally suggest that you be careful with this. A static cast is safer, or parenthesized initialization is also safer. Oh, I see what you're saying, Hannah. Calling multiple on a built-in as UB. Right. Yes. Yeah, right. You have at least an ambiguity, right? It is an ugly C style cast, but you don't have to use it. You can use a parenthesized or excuse me, a braced conversion here to still invoke the implicit conversion that you have for current match. So I recommend doing that where you can, unless I'm missing something. Hannah would be able to clarify here if I'm missing something. And for those who don't know what I'm talking about, if I did something like, so you kind of expect that to work, that's a conversion that you expect to work. But if I do a braced init, it should, nope. Are you not even going to give me a warning? You're not even going to give me a warning. Fine, let's do this a different way. Cannot convert bool to S without a version. Oh, yeah. All right. I know that I have a good example for this. I just have to come up with what it was. Oh man, what is my example for this case? Oh. Yeah, the braced init is going to be more like the static cast. It's going to invoke the conversion. Um, oh. uh, I still don't think this is going to give me the error that I was hoping to see. No, No matching conversion for function style cast. Okay, so I just wanted to point out that it's a function style cast. That's what I wanted to point out. It's as opposed to doing this, which doesn't it is not a cast. It is an explicit conversion. That's all I wanted to point out, and I think that this would be a better use case in these cases here, to use the braced style instead of the C style cast. That's what I'm suggesting. I'm suggesting it mostly because it's a safer default to be in for this kind of operation, not because it actually changes anything right here. So all right, so just to follow up with all of the comments from people here. If I do 1, then that's fine. If I do 2, then that should fail because constant expression evaluates to 2, which cannot be narrowed to type bool. But if I do parens, then it should just coerce the type, and it does. It coerces it into a bool. There we go. That's at least some kind of demonstration. Thank you collectively, the YouTube stream, for that help. Oh, the underscore attribute something versus using GNU : something. I would probably personally lean towards the attribute style syntax. All right then. So we now have questions of what happens if I do a static cast to bool of type 2. There we go. So static cast will allow that. Braced init will not. Braced init's going to be, I believe, the safest thing here. So, yeah. Yeah. All right. This tends to be, I've noticed when I'm doing code reviews, that you'll find a couple of things like comments like, oh, you should probably be using no discard here. And that doesn't apply to just one line of code. That applies to like lots of lines of code. So yeah, I'm not going to just keep repeating myself with this thing. I find this just fascinating. I'm very curious why it was done this way instead of using the not equal operator. I wonder if it's a historical artifact before Hannah had implemented the not equal operator for the begin iterator, maybe? Or does making this not equal somehow invoke infinite recursion? I'm curious about that. That's all. Ooh, yes. Use equal default to define a trivially. Yes. Let's just do that. I'm going to do that right now. That makes me feel better. All right. Yeah, we've already discussed that forever. Too much time on that. I'm curious what attribute flatten is. I don't know anything about that. It's my style where I explicitly state the relationship between operator equal and not. Okay, fine. No, it's not Visual Studio. It's Sea Lion. Sea Lion. See? Do you see the thing on the screen? No, you don't. Yes, you do. Right here. It says, it's got the Sea Lion logo, and it says jetbrains.gg/cbp tools, and it says JetBrains. Yeah, it's Sea Lion. Not Visual Studio. Okay. Smarter inlining. Oh, look. It's from Andreas Kling. Is Andreas here by any chance? I don't think I've seen him pop up. Okay. Always in line. Now for the trick. Both GCC and Clang support attribute flatten. Putting it on a function causes all its callees to be inlined into it. What? Yes, I'm suggesting using the braced initialization for the conversion instead of the parenthesized or the static cast because it's going to fail to compile in more cases. I am, yes, directly agreeing with that statement. Okay. That is fascinating. I had no idea that flatten was a thing. All right, so that's cool. Lots of static asserts, lots of const expr. I'm pretty sure I'm running out of things to look at here. And I'm guessing I've only mentioned a couple of things that Hannah was not already aware of as well. Oh, that's interesting. Why are these all yellowed? Rule is not no. Oh, I love it. All right. Now, C-style cast can definitely do some things that reinterpret cast cannot do, like convert function pointer types. So it might use reinterpret cast under the hood, but then it has something else on top of that. All right. So if you know anything about the architecture of CTRE, and I know just enough to be dangerous here, these functions are intentionally not implemented. They're just used for pattern matching and function overload kinds of things. So I find it kind of funny that we've got complaints from Sea Lion here that these are not implemented. It just keeps going. They're intentionally not implemented. That's just have to just disable that rule, I guess, in Clang Tidy if you're working on something like this. If the rule function overloads are not implemented and are only used for decal type magic, why are they not, or why are they const expert? They still have to be const expert to be able to even I don't know. Actually, I thought I was going to be able to answer that for Hannah, but that's a good question. Do they have to be Discord? Or do they have to be Discord? Do they have to be const expert? That's an interesting comment. I'm guessing they do, but I don't know. Oh, just a historical relic. Huh. Okay. That's interesting. range-like things. Some of these possibly could be swapped out with C++20 things. I don't know. Another comment to make a thing explicit. Who knows if that's accurate? Yeah, okay. Yep. I'm going to make a note on that since we're making notes. Declarations, definitions. Definitions, that's what I want. Not declarations, definitions. Hey, I got a tip. Thanks. That's fun. I think you get a compiler instead of a compiler. All right. Ooh. Okay. I'm very curious about this because best practices, well, I mean, since like okay, explicit conversion operators were added in C++11 specifically because having an implicit conversion to operator bool causes its own problems, and it's the kind of thing that like Scott Myers wrote articles about, and there's boost articles about it, and there's like boost convertible to bool, and like all of these things to avoid these problems with an implicit conversion to bool. And I find this funny that we get CLion or we get our IDE warning us here that this should be explicit conversion to bool, and a note from Hannah saying to do make this explicit. And it was only 6 months ago. Yeah, Rashawn, yes, I do have Discord. I am on Discord. You can find me on Discord. But I probably won't have time to help you with the project that you're working on. I have lots of other things going on in the moment. Aha. 3D Jason dance later on. You know what? I should have a way to just like pop up like me like dancing across the screen or something when I got a tip. That would have been awesome, but I don't have that configured yet. You can't return result of CTRE match to return bool function, and that makes me sad. Okay. Oh yeah, no, this is not C++ basics. This is me attempting to understand something that's pretty far outside of my depth and try to come up with some feedback on it. My IDE setup. This is CLion, as I mentioned before. Now let's just, because someone will ask at some point, this is the Grovebox dark medium theme. I used Grovebox on every IDE, like everything. Like my NeoVim configuration is Grovebox. My colors here are basically Grovebox. My Visual Studio colors are Grovebox. That's my favorite one. So, okay. So I find it interesting, Hannah, that you've tried making it explicit, but it causes too many other problems. I think that would be fun to dig into more, though maybe not right now. You can't return it from a function that it wants a bool. Can't return it from a function that wants a bool value if you make it explicit. Yeah, you can use it in an if expression, but you can't return it from a function that's wants a bool if it's explicit. That sounds right. Okay. Can we try adding explicit here and see what happens? Maybe a lost in keyword soup. Hmm. All right. Doesn't seem that it's triggering anywhere in the code base. Yeah. Okay. um, it probably almost certainly would break some user usage. Yes. This is one of these like no matter what you think your API is, people rely on all the behaviors of it. If has include car convert. Oh, it went away, didn't it? Oh no, wait, that's this. That's the new one from C++ 20. Never mind. Yeah, I saw one of the most recent comments from Hannah was fixing something related to Apple Clang, and I'll say Apple Clang, supporting Apple Clang can be no end of problems because you don't know what version of Clang it's actually based on. It's extremely tiring sometimes. I think even if there is 100% code coverage in test, you still don't know if you're going to break something because users can rely on weird things that you never expected. I wouldn't say that that's a surefire way of knowing if you're going to break something. I mean, it's good for sure. Um, I wouldn't add a method like toBool personally. I think this is fine. That's just a question of implicit versus explicit and whether or not you make the user. I mean, you might also have a, a matched. There probably is, isn't there? Operator bool returns matched. Oops. Okay, I might suggest that you also add an explicit conversion to bool, something just a dot matched member function or something like that. If the only way to get to it is from this implicit bool operator, but it hasn't come up yet in actual usage, so I don't know. It's hard to make the argument for it. I could see either way. Expression can be simplified. Bool, left-hand side. All right, if the left-hand side is true, I always get these like, then return this, else return false. All right, fine. Simplify the expression for me. What are you going to do? If bool and thanks, I guess. Clang tidy, but I think that would have been better so that it's easier to read. So it's if the left-hand side and the left-hand side view equals right-hand side. Yeah, I think that's a fairly good conversion. Yeah, that's a good point, Hannah. How do you measure code coverage for compile time code? That's I recommend when I'm teaching classes on constexpr that you make sure that all of your tests can work both as constexpr and as runtime things. I don't think that's possible for what you're doing, but I could be wrong. If it's possible to make some version of this where things actually run intentionally at runtime, then you could get the code coverage report. but it might require major architectural change that would not be worth it to you, I'm guessing. Apple Clang is the version of Clang when they released the first beta of Xcode. I have no idea. How is called feature that you can see git commits in line in the gray font? Oh, that's a extended Git toolbox inline blame notification is what I've got here from Git toolbox. Now let's do this. Uh, it should also be enabled in NeoVim, but it's not. Weird. Okay, maybe I disabled it because I was having problems in NeoVim. But I do have that support for both of my major IDEs that I use for editing. So Taras, let's see, if I remember correctly, it did break my slideware code. Okay. I'm catching up on comments, sorry. Yeah, we discussed const-eval earlier, but the problem being that Hannah wants to continue supporting C++17. I'll comment on that. Compile time code coverage tool. Yes, go ahead, please. Someone implement that. That'd be great. Yes, every IDE has something like this. I need mod powers to mute the trolls. You know what? I don't care about LOL1 saying use Emacs, it is better. Whatever. Who cares? No one is pasting spam and junk and whatever. The IDE is CLion. I'm using CLion. And you can check out CLion with that link right there on the overlay, jb.gg/cpp-tools. That should be viewable. Is this operator overloading what's on here? Yes, that's operator overloading. And does it make sense to use friend all over the place like this? Question is, where is this? Yes, this makes total sense. A friend declared inside of a struct is generally the recommended way of doing these things, because you can have a friend that's localized in its use, and it's necessary to see the private members and when you need that in your operator overloads. And yeah, no, I'd say this is perfectly fine, although that probably doesn't have to be a friend in this case. It looks like it's only calling public members here. So let's see. Yeah, okay. So if you're going to declare it in line with the class, then it has to be a friend. So this could be moved out of line and not be a friend, or it could be left here inside the class, inside the struct definition and stay as a friend. Yeah, they don't like friend functions because they can break encapsulation, but I'll just go back to the fact that this is already declared inside of this struct. of the captured content. So if I'm reading this right, you're already inside the encapsulated thing. So breaking encapsulation here is irrelevant. Ooh, uh-oh. Is that intentional, Hannah? Function select hides a non-virtual function from class captures. Huh. Const. The const overload hides one from its base class of captures. Oh, it hides one from itself because this thing, yeah, is inheriting from its tail. Yeah, that's, we're not even going to touch on that. Nope. I don't want to get into that right now. Yeah, equals default. We already commented on that. Yeah, no discard. We commented on that. Simplify some of those expressions, perhaps. Maybe some unused tuple things in here. So there might be some dead code floating around. All right, I think I'm just about out of code here, unless someone wants to. I am not going to comment on UTF-8 parsing. And we've already looked at wrapper a couple of times. I'm not going to dig into CTLL, I don't think, because this is specifying the grammar for the regular expressions at compile time. I'm way out of my depth there. Yeah. Oh, CTLL is the parser itself, not the grammar. Sorry. Template struct inline const expert inline. I'm curious if these inlines are useful. Explicitly inlining a trivial constructor seems like it has to be unnecessary. I could be wrong. My guess is it kind of looks like that code just kind of got caught up, swept up in an effort to add inline in places. Yeah, historical relic again, okay. That's interesting. If I had some way to pass tips back to you, I would wait for someone to comment on what kind of function declaration that is. Context-aware functions and context-aware constructors are implicitly online, yes. Yeah, but even the fact that besides the fact that it's implicitly inline, I don't know if there would be a reason to do it on a trivial constructor. No, Russian name that I can't pronounce. Inline for member functions declared within a class body is not necessarily useless. It does actually change the calculation that your compiler performs when trying to decide whether or not to actually inline that function. So, inline on member functions that are defined within a class body still can have use. Whether or not it's a good use is a different question, but they definitely can have use. Yes, so this is a C-style variadic function, which I honestly had no idea you could make them const expr. And I find it curious. I don't know if that was intentional. I'm assuming it was intentional, but I'm curious if it should have been something different. I don't know. Hello from Guatemala. Hello from India. Welcome, everyone. So Daniel is what people are suggesting, or some related pronunciation of that. Yeah, that's what I'm wondering. Well, the problem is C++17, if you wanted to do, you can't just declare this parameter auto. You would have to do an explicit template. It could have been a variadic template. Yeah. But I'm guessing this is faster to compile, like considerably faster to compile. How inline affects those functions defined in the class body. One moment, please. What I can give you is the tools to further research it on your own, but I did just verify this like last week. So that is a link to one of my YouTube videos about how inline affects the optimizer. And if you play around with that, the code examples in here, then you can also play around with making your public your class members inline or not. It literally just came up as C++ now a few weeks ago, and I just verified that this is still true just then. So I'm sticking to my story. All right. I just pasted that link to the chat, by the way. Yeah, yep. It's a C++ weekly episode. I haven't done a conference talk on it. I don't think I have. Anything's possible. I don't feel like there's going to be much new to say. It's interesting how many things it thinks is never used. Might be worth just looking into that and see if any of this is dead code and should be removed. Hannah, I don't know. Yeah, I think well, it's been nearly 2 hours, and I don't think I'm going to find anything else to say in here. So I guess I'm going to start to wrap this up. If anyone has any other questions or anything, I'll stick around for a few more moments. What is the purpose of the function at line number 60? Oh, goodness gracious, that was a while ago. Let's see if I can get back to location 60. Is that what we're talking about, this one? If you are past a t, then you return true. Otherwise, you return false. I don't know. I'm saying I have a very strong hunch that this is going to be much faster to compile. And I don't know. Hannah hasn't. Oh, there we go. She did make a comment here. There might be a very good reason to do this to get better compile time. But I'm not sure. Okay. All right. Well, thanks everyone for hanging around for the last couple of hours. I hope this was useful to someone. And yeah, I mean, like I said, I would have used Sea Lion in here anyhow. So check out the link if you want to check out the IDE yourself. But otherwise, I am going to hear a programmer from India with such pronunciation. I don't know who you're talking about. All right. So anyhow, thanks everyone. I will catch you in a later stream.